My name is Peter Chekmaryov. In this presentation, I will tell you about custom polylines and Linetypes 3D. This is a proprietary product, so first I want to say special thanks to MicroSurvey software for their permission to demonstrate the results of our common work. The definition of Linetype 3D can be applied to every object simple enough and periodical from which we could pick out a base curve. For example, road markings and other road objects as concrete dividers, also fences, power lines, and pipelines. Put simply, this is just a method of drawing baseline ideologically similar to usual line type. A few words about our implementation. Firstly, we determined that it would be best to create a custom entity for applying the Linetype 3D tool. So we could properly support grip and jig behavior. We decided the custom entity should be derived from a polyline entity, and we could use the polyline geometry as a base curve, so we called it custom polyline. Usual linear entities accept usual line types as a property. So custom polylines accept Linetype 3D as a property too, as analogy. Secondly, the set of line types are defined by a configuration XML file, but each custom polyline can be customized in real time in the current drawing. Applying a Linetype 3D to a custom polyline set its state to the Linetype's default. And thirdly, the set of line types is divided into so-called Jentypes. This word means generation procedure type. Jentypes are different in code of realization, definition in memory, and in configuration file. Now I will show Linetypes 3D of different Jentypes and describe how they work. Jentype Profile. Basically, all presentation is just showing parts of configuration file. A Jentype profile allows us to describe any length of object with a uniform cross-section. Let's take curve as the first example. The upper XML node defines the Jentype. Subnode name is the name of Linetype 3D. The second and most valuable tag is cross-section. Inside, tag type defines type of cross-section, which could be hollow or solid. In vertices section, we have definition of polyline, of two-dimensional polyline that describes a cross-section of itself. In this polyline definition, we can use linear segments and arc segments too. Let's see how this looks in practice. Oh, no, sorry. I call our comment a line type. Take certain line type, 3D, and start drawing it like usual line type. Insert in first point. Choosing arc submenu, set direction. And set endpoint. So we have arc drawn with Linetype 3D curve 6x4. And different visual style. This looks like this. I should also draw your attention to the meaning of XML attributes of cross-section tag. These attributes define properties which can be modified at real time and set names of these properties. Here we can choose only two change only two properties. Height of this curve, and also width of this curve. Example of culvert illustrates that we can change the diameter of cross-section along baseline, although its form is fixed. We can set this behavior through the width distribution section, where we must set the diagram of width distribution section, where we must set the diagram of distribution to a relative diameter. Although cross-section for culvert is circumference, when we will draw it with culvert, this we do not get a cylinder as a result. This is what we get. The scale axis section sets defines the stationary point of scale transforming. Cross sections are also used for describing fence posts and the rails between them. Jentype fence. The name speaks for itself. Any fence contains posts. It can optionally have rails and wire netting. Look at the tag max interval. This defines distance between posts. Usually this value is modifiable. That's why we have here a property tag too. For determining a post, we can use a symbol loaded from an external file. This these lines refers to the file from which we should load the symbol for post and describe which of block in this file we should use. Now I'll show you this file. I'm going to demonstrate the post symbol for you. Sorry. This is stored in system folder. Linetype config open. Yes, I want to do this. So I'm using insert command for showing our symbol. For example, guardrail bilateral post. So this symbol will further appear in our custom polyline. This is post. Realistic. Pitch down. Another way to draw a post is to set its cross section. The cross section has the same format as in the profile, and also we have here height of bottom and top of post. The rails are defined by start and ending points coordinate relative to post start point and end point. That's how we set the baseline to which we will apply the profile of a rail. This is the same cross section, tag and section. We can also set the boundary for wire netting using relative coordinate in the same style as coordinates for rails. And also we can change here, set here step for chain link. Let's see how this guys looks like. First, guardrail bilateral. These posts, as you can see, they are absolutely similar to this one, which was an external file, external symbol file. And this is chain link looks like. And also there was horse fence, wasn't there? Jentype symbol. Often it's necessary to simply stamp many symbols along the baseline. This primitive behavior is described by the Jentype. Let's take road cons as an example. Using the max interval variable, we could set the distance spacing between the cone symbols. We can also fix the color. And I'll show you directly. We cannot even try to change the color there. This field is disabled, and combo box will now have an ability to show the list. There is different ways to try to set different color, but even if we will change the color of entity, that color will be just ignored. Jentype linear. Essentially, this is a repeating of usual Linetypes functionality with some extra features. Usual Linetypes is a sequence of lengths of stripes and gaps between them. About features, firstly, we can fix color too. Secondly, we can directly set the width of line. Thirdly, using the familiar expression, we can define symbols instead of linear segments and arcs. There we have external block, same as it was in fences where we described posts, same as it was in symbol Jentype. Let's see how they looks like. Oh, sorry. Single dashed white. There we have two big gaps between stripes, so it's look not so impressive. So symbolic, linear. Linear with symbols. We have here squares line. These squares are symbols loaded from this file. Jentype Combined. Some of the line types can be presented as a combination of others. Road marking lines are a clear example of it. As you see, we define these line types by describing line type. By defining pairs of line type and shift from baseline. Baseline is somehow noticeable with points, with grip points, but lines itself are shifted aside. Line types that are components of Jentype Combined can be defined not only by what's going on here? Not only by name, but by unnamed line types as well, defined directly. For example, divider half with rail. There we have shifted straight pair, and instead of just using name of some line type, we just define it right here. Define line type right here. By the way, this is non-trivial example of Jentype Combined. Three weeks ago, we added an ability to change the view of custom polylines, customizing them in runtime. So Linetype 3D just defines the default state of custom polyline that can be changed by the user with the help of the property palette. Here you can see a list of customizable properties. I don't understand. But I will show it directly in program. The most various example is fence. We can change the height of post. We can change width of post. We can change length of post. Of course, we can change spacing between them. We can set the elevation of different rails. And even change diameter of them. For Jentype symbol, we can change. Let's take accounts. We can change common size of symbol and change distances between them. 5. For profile, as you remember, we can change sizes of profile, widths, and heights. For combined, we can change spacing between lines. Line spacing. And change widths of lines. It's too much. Of course, we can, for linear, we can change lenses of stripes. Dash lens here. And lenses of gaps between them. Lastly, I want to discuss the infrastructure that maintains custom polyline. The first big part of it is a command and jigs written for this command. We just used as an example usual polyline command. So we derived all submenus or options from it. We can set distance before entering the next point. We can, of course, use arc segments, and for these arcs we have very many different options, like setting center before drawing, or using second point for drawing. Of course, there is very many options, so I will not show in all of them. Let's draw something. Grips and snaps were also derived from the standard polyline entity. Therefore, snaps and grips behavior match polyline behavior, and the complexity of the Linetype 3D objects are ignored for snaps and grips. In truth, this is impressive too. I think I will change it to bridge tabular. Of course, we can snap to the baseline. For example, we'll try and etc. Well, I think that's all from me. Do you have any questions?